This is Mr. Anderson for Kellogg Community College. We are looking at Section 5 of Chapter 7, expressions containing several radical terms, and we're going to be doing a lot of different things to take care of terms that have more than one radical in them, and in some situations radicals with different indexes. This is going to be the first of 3 parts. So we're going to start off today with looking at adding and subtracting radicals, and start off with just a simple concept from algebra. If we have x and then we're adding to this maybe 3x, we can do so by looking at the coefficients in front of these common terms. So 1x and 3x would make a total of 4x. The same thing will go with any kind of radical. So if we have the square root of x plus the square root of x, the answer is 2 square roots of x, which is different than saying square root of x times square root of x, which would be the square root of x squared, or just x. So it's interesting to look at these two ideas and not get them confused. So this would be 1 square root of x plus 1 square root of x is 2 square roots of x, and this is square root of x times square root of x, which is the square root of x squared, or you're adding the powers in the corner. 1 plus 1 is 2, and therefore the square root of x squared would be x. So keeping that in mind, you'll notice that in this problem you see where we have these being exactly the same, the fifth root of 2, so 14 fifth root of 2 minus 8 fifth root of 2 is going to be 6 fifth root of 2. So you can change the fifth root of 2 doing a little mental substitution to say 14x minus 8x is 6x, except in this case the x is the fifth root of 2. Here, kind of the same thing. Imagine all of these square roots of 6's were the same variable, like y, y, y. So therefore 1y plus 3y minus 8y is going to be 4 minus 8, which is negative 4 square roots of 6. Alright, looking down here, you'll notice that this is the square root of 50 and this is the square root of 2. There is no commonality between the square root of 50 and the square root of 2 right now, so we cannot combine this to make, let's say, 5 square root of 48 or 5 square root of 52 or any other kind of manipulation like that. We have to have the exact same number under the radical to get them to be simplified. Well, what's nice about this is using our root chart from our previous worksheets here, we can see that you can break this into 9 times the square root of 25 times the square root of 2, which then the 9 times the square root of 25 is the same thing as 9 times 5, and the 9 times 5 is 45 square roots of 2 minus 4 square roots of 2, which is going to be 41 square roots of 2. So once you have your common square roots, you can put those together. Sometimes the problem is easily solvable because the number under the radical is completely rootable, which means that if you have the cubic root of 27, that's an answer of 3. Minus 5 times the cubic root of 8, which in this case is 2. 3 minus 10 is going to be negative 7. Alright, looking at some more examples here. Now the cubic root of 54 is not perfectly rootable. So if you actually kind of look at problem 5 and problem 3, you can see they're kind of the similar problems, except that one's in the cubic root and one's not. So let's focus on just the first cubic root here. Is there something I can remove? Well, 54 is dividable into 2 parts, 27 and then the cubic root of 2x. Now you've seen I've taken out the thing that's perfectly rootable and put it in its own cubic root, and the things that cannot be cubic rooted, the 2 and the x, well, they have to be left behind. So the cubic root of 27 is 3, so I've got 3 times the cubic root of 2x minus. Now over here, the thing I can remove is 3 goes into 4 once, so that leaves me with an x. And then that leaves inside here the cubic root of 2x, because there would be 1x left over. 3 goes into 4 once, with 1 left over. So this means I have now, under the cubic root, the same thing. Cubic root of 2x, cubic root of 2x. So this becomes 3 minus x and since we don't know what x is, we're just going to have to leave it as a variable, times the quantity of 3, the cubic root of 2x. Alright, moving on to number 6. You can see, we'll try to see if there's anything I can factor out of this problem. It looks like I can factor a 4. Now I've got x minus 1 under the radical. We can split this into the square root of 4 and the square root of x minus 1. And the square root of 4 becomes 2 times the quantity of the x minus 1. Over here, I can remove a x squared inside of my radical, which makes x minus 1. Now you're looking over here to the other radical, you see the x minus 1. We can pull this square root of x squared and square root of x minus 1. This is using the product rule. Simplifying this becomes x, and then we have x minus 1. So now I have 2 square root of x minus 1 minus x square root of x minus 1. So this becomes 2 minus x times the square root of x minus 1. Okay, now looking at problem number 7. Problem number 7 and changes things a little bit, because instead of pulling something out of these square roots, what we're going to be doing is distributing. And perhaps we can get things to be a little bit more simple. So let's do a little bit of distribution from here to here. 4 times now there's a number in front of these here, we'll just put some 1s there. 4 times 1 is 4, and 2 times 3 is 6. 4 times 1 is 4, 4 times, the square root of 5 times no other square root, or 2 here, square root of 5 times square root of 2 is 10. And this is the end of our answer. There's nothing more to actually do or simplify in this. Sometimes there can be, but in this case there isn't. 4 times 1 is 4, 4 times 1 is 4, 2 times 3 is 6, 2 times 5 is 10. Using the product rule, we can put things together if and only if they have the same root. So if we look at number 8, you're going to see that each of these problems, that cubic root of 2 is going to go inside where all the other cubic roots are. So the first number becomes, instead of the cubic root of 4, the cubic root of 8. And here, the cubic root of 2 times the cubic root of 32 becomes the cubic root of 64. The 2 stayed the same, and the number in front of this also stayed a 1. Now, what's nice about these is that you can see that the cubic roots will actually simplify. The cubic root of 8 is 2, minus 2 times the cubic root of 64, and the cubic root of 64 is 4. So here, I'm going to rewrite the problem, 2 minus 8, and 2 minus 8 is negative 6. When we get to a problem like 9 through 12, we're going to get to FOIL. And FOIL is an important part before we get to the second of our 3 videos for this worksheet. So FOIL still follows first outside, inside last, or 4 times 2, which is 8, 4 times the square root of 5, which is 4 square roots of 5. Then we go negative square root of 5 times 2, which is going to be negative 2 square roots of 5. And then we have negative 5 negative square root of 5 times positive square root of 5 is negative square root of 25. Now we have some simplification to do. The middle two terms can always get together, so we have 8 plus 4 minus 2 is 2 square roots of 5. Imagine if this was an x, this would be 4x minus 2x. Now this here is kind of interesting because the square root of 25 is 5. So here I have the square root of 5. What's kind of neat is that these last two terms in the L cable will always simplify. So what we then get is 8 minus 5, which is 3, and then plus 2 square roots of 5. In terms of how we will write these, let's keep to the order that we'll put anything in front that is not part of any root or radical, and then we'll add or subtract to that anything that does have a radical by it. Now, problem number 10 gets a star because problem number 10 goes into the second video, which is talking about rationalizing denominators that have binomials. Notice that there's a plus and a minus here. Well, something nice is going to happen when we have a plus and a minus, because the first two terms, they get squared. Now, when we do the second two terms, so this is minus 3 square root of 11 and plus 3 square root of 11, you'll notice that these two are opposites and they will simplify to 0. So that's important. When we have the difference of these binomials, where one is one way, one is the other way, the middle terms, when FOILed, will simplify. And our last two terms, which is going to be 1 square root of 11 minus 1 square root of 11, is going to be negative 1 square root of 121. What's important about that is that our first term, our second and third term go away, and our fourth term are going to be whole numbers. And then we can simplify that to be negative 2. So keep this in mind for our second video. When we are trying to get rid of all of our square roots or cubic roots or whatever roots we're talking about, FOIL might be an option. And we will see that on our next part of the video, where we're going to be trying to get rid of square roots in the denominator that are binomials. Alright, so moving on to problem 11, and since I want a little more room here, let me clear off my work and get back to a nice clean screen here for number 11. Okay, now be careful when we do all these cables. 4 times 8, or 4 times 2 is 8, and square root of 5 times square root of 5 is 25, which is going to be 8 times 5. Now that's the first term. Then we're going to go 4 times 4, which is going to be positive 16, and the square root of 5 times square root of 2 is square root of 10. This cannot be simplified. Then we're going to do this inside cable here. Negative 3 times 2 is negative 6. 2 times 5 is negative 10. The negative 10 cannot be simplified. And then we're going to move from this negative 3 to the positive 4, which is negative 12. And negative square root of 2 times negative, and square root of 2 times square root of 2 is going to be square root of 4, which could be simplified to negative 12 times 2. So 8 times 5 is 40. 16 square roots of 10 minus 6 square root of 10 is negative 10 square roots of 10, which cannot be simplified any further. And then minus 12 times 2 is negative 24. 40 minus 24 is going to be 16 minus 10 square roots of 10. And that's your answer. Now, please do not follow in the mistake that most people make with problem 12 by saying, oh, this is just 25 minus 9. No, the 2 does not get distributed that way into the problem. This problem has to be written twice. The square root of 5 minus the square root of 3, and the square root of 5 minus the square root of 3. Because that exponent, the little 2 on the outside, means I want 2 of them. And you're maybe thinking of a problem if I had the square root of 5 times the square root of 3 squared, yes, I could just distribute that to the inside. But since this is a binomial, you cannot do this technique with this problem here, even though it was legal until I put the subtraction symbol between them. So let's do our FOIL. Our first brackets here are the square root of 5 times square root of 5, which is the square root of 25, or 5. Then the square root of 5 times a negative square root of 3 is negative square root of 15. And then the negative of square root of 3 times square root of 5 is another negative square root of 15. Notice that the negative is on the outside and not the inside. The negative of square root of 3 times the negative of square root of 3 is positive square root of 9, which will simplify to 3. 2 negatives make a positive here. So therefore, I'm going to take my 5 and put it with the 3. That's going to be 8. And the negative square root of 15 and the negative square root of 15 do not cancel out or simplify to 0. It becomes minus 2 square root of 15. And the square root of 15 cannot be broken down into a smaller number. And that ends the first of our 3-part video for this section. Thank you for watching.